In this video, we are going to talk about second order non-homogeneous differential equation. Yeah, second order non-homogeneous differential equation. In the first video, we've talked about second order homogeneous differential equation actually. And we said that for homogeneous differential equation in second order, it looks like this. Okay, let me come here. A d square y dx square plus b dy dx plus cy equals 0. Alright. If the function at the right hand side is 0, then the differential equation is said to be homogeneous. But if the function at the right hand side is not equal to 0, it is equal to something else, say an algebraic function, exponential function, trig function, logarithmic function, or whatsoever. As far as f of x here is not equal to 0, it is classified as a non-homogeneous differential equation of the second order. You get it? For a non-homogeneous second order differential equation, the solution of the equation is usually like this. Y equals complementary function CF plus the particular integral. Yeah, plus the particular integral. I think it is necessary and important for you to watch the video on second order homogeneous differential equation, because the foundation of this particular non-homogeneous is coming from homogeneous. You get it? So some of the stuff I'll be saying here while solving is only coming from the knowledge of homogeneous differential equation. A quick recap. You know, if I solve this differential equation, what we normally do, we reduce this differential equation into the d operator form, as the operator d form. And if I want to do that here, it will be a into d square, you get it, plus, okay, look at it, d square y plus b dy plus c y equals 0. And if I bring y outside, it's going to be a d square plus bd plus c into what? Y equals 0. Then what we now do, I'm speaking based on the previous knowledge coming from homogeneous differential equation. Alright? But we still have to apply it here also. That's why I said you should watch the video so that you understand basically what's going on here. What we now do is we'll create or we form what we call the auxiliary equation. And for the auxiliary equation, I'll rewrite this bracket like this using a variable n to look like this: am squared plus bm plus c equals 0. This one is called the what? The auxiliary equation. Then we will now solve this, usually quadratic. We now solve this quadratic equation that is auxiliary. Alright? And you know, when we solve a quadratic equation, we're going to get two values for m. So we now say that let m be equal to alpha and m equals beta. This alpha and beta, they are the two roots. Let's call this m1 and let's call this m2. So let's say after solving this equation, this auxiliary equation now, we get m1 equals alpha, m2 equals beta. Three cases can actually come out from this root. Look at it. Case 1. If alpha is equal to, okay, let's say if alpha and beta are real and they are different, they are real numbers and they are not equal to each other, it means that the solution to that particular equation will be equal to a is a constant, exponential alpha x plus b exponential beta x. This is the first case, the case where alpha and beta which are the two roots of this auxiliary equation are not the same. What if alpha is equal to beta? We now say that the solution is y equals ax plus b into exponential alpha x. In this case now, alpha and beta they are the same thing. Let's say m equal to 2 and m equal to 2. So we just pick one of the two. That's the solution. And what if the roots are complex? That is, let's say we get m equals alpha plus or minus I beta. What will be the solution to that second order differential equation, the complementary function? What will it be? We are going to say that y is equal to exponential alpha x. Take the first one, exponential alpha x, or e to the power of alpha x into a sine beta s plus b cos beta x. Also, we are still using beta. This is alpha. Then inside the bracket, we use beta. So this is complementary function. I talked about this in the first video on second order differential equation, where we're talking about the homogeneous type of it. So while we're still trying to solve questions under non-homogeneous, we are going to follow the same procedure. That's why I'm doing a quick recap of this. Now, for non-homogeneous second order differential equation, the solution is usually in the form of y is equal to the particular integral plus the complementary function. I wrote it there. This is what I wrote here, and they are the same. They are the same thing actually. I can use anyone. Yc complementary function, this. Yp particular integral, this. Yeah. So if it is homogeneous, this will just be the solution. Again. But when it becomes non-homogeneous, we now determine the particular integral, and that is where the work is actually. So I have some functions on the board. If I'm solving a second order differential equation that is non-homogeneous, and I'm having a function at the right hand side that is a constant. What will be my particular integral? This is the guess. Let v, I'll be using v all through as the particular integral. So just follow me. So if, for example, I have a d squared y dx squared plus b dy dx plus cy equals 4. 4 is a constant. My particular integral v should be a constant. Okay. Yes. What if in that complementary function, there are some cases where we don't just have to choose k like that. We have to look at the complementary function if there is a constant in that complementary function. And if there is a constant in that complementary function, it implies that my particular integral becomes b equals kx. Look at the second case. If f of x is a polynomial, mx squared plus nx plus l, alright, a polynomial in terms of x, this is what the particular integral will be. V, this is for the first case, and we have, okay, this will be v equals, okay, I will choose a new polynomial. Let's use a squared plus bx plus c. Okay, that will be particular integral. In this second case, there is no snag case. By snag case, I mean that the complementary function does not behave too differently. Yes. When I'm solving questions, you understand what I'm saying. What I mean by snag case. I have a lot of questions to solve to exhaust as much functions as possible. So stay tuned and watch the video to the end to see how the solutions to the questions will come out. It must not be a polynomial. If, for example, I have f of x equal to mx squared plus nx plus m, fine. This is my particular integral. If it is just mx squared alone, this will still be my particular integral. Yeah. If it is mx, check. The degree of x here is 1. So what I will be choosing as my particular integral will be this. I'm not going to put x squared, bx plus c. I hope you understand what I'm saying. The degree of the function determines the degree of the particular integral. Yeah. So if I have mx squared plus nx plus l is going to be ax squared plus bx plus c. And that is the particular integral. Okay, let's see. If I have an exponential function, e to the power of ax, let me change this a to something else. Let's say k, so that the a here will not be the same as the one here in the sense of it. This is the particular integral. The particular integral is simple. Choose another exponential function, the same thing, e to the power of ax. You can now use b. You get it? So if I have a function, if I have something like let's say 5 exponential 3x, all right, my particular integral in this case will be, let's say, I can use any constant, let's say b exponential 3x. That's what I mean. This will be the particular integral for this kind of a function. You get it? So this is one case. What if exponential ax appears in the complementary function? If I solve a second order differential equation that is non-homogeneous, and for the complementary function, what I get in the complementary function, let's say in this kind of a case now, I'm having a exponential 5x. And in my function, I have, okay, let me use 3x. In my function, I have exponential 3x in the function at the right hand side. And in my complementary function, I'm having 3x as well. Then I will not choose this. This will not be correct for the particular integral. So I'm going to modify it. B will be equal to, I will simply multiply this by x to get b x e a s. That will be the particular integral. You get the story. Now, there's another case. This is snag case 1. I've considered the first case. This is the general case. And this is the second case where we have EAX appearing in the complementary function. Now, there are cases where this and this will appear in the complementary function. So if this and this appears in the complementary function, the particular integral becomes b equals b s squared EAX. That's it. It's very easy to understand. So if you check, it's just to be increasing the power of x here by 1. Finish. If I have a sine or a cosine function or both, yes, I can have cos x standing here. Or let me get my wiper. Can have cos x standing here, or let's say cos 3x, or I can have sine 3x, or I can have cos 3x plus sine 3x. You get it? The combination of the two of them. So, how would I have here? What then should be the particular integral? The particular integral should look like this. I have a sine px plus b cos px. So I should choose, let's use another constant. Let's say k sine px plus, let's use z as the second constant. I've used k, I want to use z now, cos px. That's the first case. So there's another case, alright. Most times these snag cases are not common, but it actually depends on the examiner, the exam you're writing. Okay. So if this appears in the, if this appears in the complementary function. Yeah, we can have something like that. Yeah, you get it. If it appears in the complementary function, then the particular integral will be v equals, just multiply this by x into k sine px plus z cos px. That's it. So is it all the time that we just have a single function at the right hand side? No. We could have functions that are a sum of two or more functions, or a product as well. So watch the video to the end and see how we are going to evaluate or determine the particular integrals of functions that are either sums or products. Let's go. Example 1. Alright. Let's have the first question we have. This is 2d squared y dx squared plus 5dy dx minus 3y equal to 6. I want to determine the general solution to this second order non-homogeneous differential equation. Alright. So what we normally do, like I said, the solution is usually in two parts. It is the sum of the complementary function and the what? The particular integral. Let's first of all determine the complementary function. To start, I'm going to write this differential equation in d operator form. Don't call operator d form. So it's going to look like this. 2 into d squared y plus 5 into d. So what this means is that d squared represents d squared dx squared. You get it? Yeah. Then d represents d dx minus 3y equals 6 in d operator form. There is y. Oh, this is supposed to be dy. y. The three functions, I can factor it out. This will be 2d squared plus 5d minus 3 all into what? Y equals 6. From here, we now calculate we now determine the auxiliary equation. And like I said earlier, for the auxiliary equation, it will be like this: 2m squared plus 5m minus 3 equals 0. Yeah, this is the auxiliary equation. Forget the y, forget the 6. Set this one equal to 0. Replace d with m. So we now solve this quadratic equation. This is 2 times minus 3, and that's minus 6, right? So two numbers when multiplied to give me minus 6, when added to give me 5 plus 5. Okay, when multiplied to give me minus 6, added to give me 5, I can choose 2 times 3. So give me minus 6, I need, okay, I can't use 2 and 3. I think I can use 6 and 1. Let me check. Okay, 6 times minus 1 is minus 6. 6 plus minus 1 is plus 5. Good. So I have, this is 2m squared plus 6m minus 1m minus 3 equals 0. 2 is common. Okay, 2m is common. Bring 2m outside. I'm having m left plus 6. What's common here? Sorry. What am I first? 6m divided by 2m, that will be 3. What's common to this? I have negative 1, bring it outside. Negative m divided by negative 1 is positive m. Minus 3 divided by minus 1 is what? Plus 3 equals 0. So the two brackets are the same. I have m plus 3. Bring out 1. This is 2m minus 1, which is 2m minus 1 equals 0. I'm doing quadratics, you know that. So if the product of two numbers is equal to 0, it means that n of numbers is 0. And that means either n plus 3 is 0 or 2m minus 1 is what? 0. From here, n is equal to negative 3. Or from here, n is equal to positive 1 over 2. So we have gotten the values of m from the auxiliary equation. The next step is to determine the complementary function. So the complementary function, let me use Ci. I will tangent Ci and Yc. It is going to be like this. Check, remember, when the two roots are real numbers and they are different, the format says complementary function is equal to a exponential alpha x plus b exponential beta x. Alpha is minus 3. You get that? And beta is negative, okay, positive 1 over 2. Let me take this again. 1 over 2 x. This is the complementary function, straight up. So the next thing to do is to determine the what? The particular integral. Then we'll add it up to this. That gives us the solution to this equation. Now, how do we do particular integral? Look at the function again. Let me come from here. At the right hand side, what do we have? We have a constant, 6. What did I say about the particular integral if the right hand side is a function? So if it's a constant, I will assume a constant, k. Check, there is no problem in this complementary function. Do you know why? This complementary function does not contain a constant. For that reason, I will not use kx as my particular integral. I will use what? K. Yes, so if there were to be a constant attached to this sum, then I would have used kx. But since there is no constant, then I will just use k. So I will say, let the particular integral, which is equal to yp, which is equal to, let me use v. Yeah, there's no problem with what I'm writing. They are all the same thing. And let v be equal to what? K. You know why we're using k, right? Because it's a constant here, and also this does not contain a constant, like a number added to it or subtracted, depending. I'll come here. Come here now. Come here. This is 2 d square. Are you there? I can just come here. They are the same. Replace this y with k. Plus, this is 5. D. Replace this y. Okay, all the y, they are all k. As a matter of fact, that's the k minus 3k equal to 6. In this case, now the 6 will come in. You get it? But when you're doing complementary function, it's disappeared. You get it? Check it. But when we are calculating for the particular integral, it's going to come in. Replace all the y with k. What this d squared means is second derivative. This d means first derivative. This is a constant. K is a constant. If I differentiate a constant, what will I get? I'm going to get 0. Even if I differentiate the constant 10 million times, it is still 0 I will get as the derivative. So as a matter of fact, differentiate k a constant. This is 0. This is 0. This one remains. This one remains. You get it? That one's going to remain. So what I'm having here is that k is equal to 6 divided by minus 3. It means that k is equal to minus 2. That's the value of k. And k here is the what? The particular integral. And as a matter of fact, the solution to this differential equation is the complementary function plus the particular integral. And this is a e to the power of what? Negative 2x plus b e to the power of negative 1/2 x. Then you add the minus 2 to it. This is the solution to that question 1. The general solution. There is general solution and there is also particular solution. For particular solution, they are going to give us some boundary conditions. At x equal to 0, the y dx is this. You get it? But the question didn't state anything like that. Make sure you subscribe, make sure you like, and share it with your friends and to your classmates. Alright, let's see the second question. So let me go straight. Let me go straight to the operator D form of this. It's going to be 6d square y plus 4 plus 4 dy minus 2y equals 3x minus 2. Alright, let me factor the y out. So it's going to be 6 into d squared plus 4 into d minus 2 all into what? Y equals 3x. Alright, auxiliary equation. Okay, it's going to be 6m squared plus 4m minus 2 equal to what? 0. Remember, the auxiliary equation is always set equal to 0. That's it. Then, let's solve this. As a matter of fact, I can cancel. 2 is common to these 3 terms. So if I divide, I'll be getting 3m squared plus 2m minus 1 equals 0. Let's solve. 3 times minus 1 is minus 3. Minus 3. And I have plus 2 here. So two numbers, when multiplied, to give me minus 3. When added, to give me 2. It is only 3 and 1 that I will try to give me 3. But to add and get 2, it means the 1 must carry a minus. So that 3 times minus 1 is minus 3, and 3 plus minus 1 is 2. So I'm having 3. I don't even have to solve. I don't have to solve. Yeah, let me just show you the shortcut. I chose 3 and I chose minus 1. So here's the solution. It's a short way of solving quadratic equations. This 3 is carrying a plus. Change it to minus. Change it to minus. This 1 is carrying a minus. Change it to plus. That's step 1. Any sign that you have, switch it to the other one. If it's plus to minus, if it's minus to plus, then you divide by what? You see the coefficient of m squared, which is 3, divide two of them by 3. So what this means is that m is either minus 1 or m is equal to what? 1 over 3. Okay, it's straightforward. So I just follow this step in the first example to solve and show you how to solve quadratic equation by factorization method. So you can also do this. This one is easy. You get it. So m is minus 1 and 1 over 3. The two roots are real numbers. The two roots are different. They are not equal to each other. It means that the complementary function is equal to a e to the power of minus x, that's minus 1x, plus b e to the power of what? 1/3 x. So let's go. Particular integral. Let the particular integral be equal to y, which is v. All with v now. All with v. All with v. Check. At the right hand side, what will you call this? Will you call it a polynomial or a sum or a difference? It's a function of x, 3x minus 2, an algebraic function. This is actually a polynomial. Yes, it's a polynomial of degree 1. What I mean degree 1, the highest power of x is equal to 1. So if you check that, those functions I wrote earlier, when I was giving the different cases for the particular integral, I said that for a function like this, I said if it's a function of x, here we have y equals, let's say, ax squared plus bx plus c. The particular integral should be another function like this of degree 2. You get it? Something like kx squared plus mx plus n. Good. If the function is y equal to ax plus b, then reduce the particular integral to kx plus n. Simple. So as a matter of fact, the particular integral here, let's use that kx plus n. For the reason being that we are having a polynomial of degree 1. So let's choose a constant, a function of x whose degree is 1. Alright, let's go now. Mind you, if I differentiate kx plus n. If I differentiate it once, n is a constant, it gives me 0. Differentiate kx with respect to x is going to give me k. This one is first derivative. If I differentiate ks plus n 2 times, which is second derivative, first of all, do the first one, we got k. Differentiate k to get what? 0, this second derivative. So there's a reason for doing that. I want to plug those answers here. Yeah, here. Or here. So for the particular integral, I will now have 6 v squared v, remember, plus 4 dv minus 2d equals 3x minus 2. Okay. What's v squared v? V is what? V is kx plus n, right? This is 6d squared kx plus n plus 4d kx plus n minus 2 into kx plus n equals 3x minus 2. When I differentiated kx plus n once, I got k, right? So this is going to be 4k equals, okay, I have minus. This minus can only expand this bracket to give me negative 2kx negative 2n equals 3x minus 2. Then, when we differentiated kx plus n 2 times, we got what? 0. So if I multiply 6 by 0, it's going to give me 0. So what's left? This is 4k minus 2kx minus 2n equals 3x minus 2. We are looking for k and n in this equation. Now, there are some functions here, actually one of them in terms of x. This is 4k, purely a constant, minus 2n, purely a constant. Only this one at the middle is carrying x. So I will equate the coefficient of x here, which is minus 2k, to the coefficient of x here, which is 3. We call it the method of comparing of coefficients. So equate coefficients and solve. 2 minus 2 is a constant. 4k is a constant. Minus 10 is a constant. If I equate, I'm going to get 4k, which is a constant, minus the other constant is equal to the constant. Simple. From here, k will be equal to minus 3 over 2, right? Yes. So if k is minus 3 over 2, we now have to use this to get n. That's the idea. So look at it. This will be 4 times minus 3 over 2 minus 2n equals negative 2. 2 here is 1, 2 here is 2. 2 times minus 3 minus 6 minus 2n equals negative 2. Minus 2 plus 6. If minus 6 crosses, it turns to a plus. Right? So minus 2 plus 6 will give me minus 2 plus 6 will give me 4. And I have minus 2n. So divide both sides by minus 2. It implies that n is equal to negative 2. So n is minus 2 and k is minus 3 over 2. What then is the particular integral? The particular integral will now be replace k with minus 3 over 2, replace n with minus 2. So the particular integral v will be minus 3 over 2x. Okay, I want to use y, p. They are the same thing. Minus 3 over 2x plus n, and n is minus 2. So let me just say minus 2. This is the particular integral. And the complementary function, based on what we got, is this. So it means that the solution to this equation is y equals a e to the power of negative x plus b e to the power of 1/3 of x. Then I'll add this one to it. Minus 3 over 2x minus 2. Determine the general solution of the differential equation d squared y dx squared minus dy dx minus 6y equals 2e to the power of x. All right, let's solve. This is d squared y dx squared, okay, minus dy dx minus 6y equals 2e to the x. So let's write this in operator d form. It's going to be like this. This is d squared y minus dy minus 6y equals 2e to the x. So let's create the auxiliary equation. It's going to be like this. Okay, before creating the auxiliary equation, let's factor out y. It's going to be d, as usual, d squared minus d minus 6 all into y equals 2e to the x. And then from here, we now form the auxiliary equation. Okay, so the auxiliary equation is going to look like this. M squared minus m minus 6 is equal to what? 0. So we'll try to solve this quadratic equation by looking for two numbers whose product is minus 6 and whose sum is minus 1. 2 times minus 3 is minus 6, and 2 plus minus 3 is minus 1. So the equation is this now. We have m squared, all right, plus 2m minus 3m minus 6 equals 0. Let's factor it out. We have m into m squared divided by m is m. 2m divided by m is 2. Then we have minus 3. Minus 3m divided by minus 3 is m. Minus 6 divided by minus 3 is plus 2 also. Everything is equal to 0. So we have this now. Bring out one of them. We have m plus 2. Then we have m minus 3 equal to 0. And this implies that m is equal to minus 2 or m is equal to 3. So this is what we get from solving the auxiliary equation. All right. So these two roots, minus 2 and 3, they are real numbers and they are not equal to each other. Okay? They are real numbers and they are not equal to each other. So what we'll do is this. The complementary function complementary function is equal to e to the power of minus 2x plus b e to the power of 3x. This is the complementary function. So the next thing now is to find or determine the particular integral. Looking at the equation, we have at the right hand side 2e to the power of x. And we said that if we have an exponential function, the guess for the particular integral, in this case, should be k(ax) also. That's the particular integral for this. So let's see. Let the particular integral v, of course, particular integral is pi, be equal to ke to the x. All right, so we now plug in this into this operator d equation, this one. Let's do that. So we have d squared minus d, okay, minus 6 into y equals 2e to the x. Okay, what would this give? The y in this case is the kex, which is the particular integral. So we have d squared minus, okay, minus d minus 6 into ke to the x equals 2ex. So let's expand our bracket. We're going to get this square times this, that's this square into kex. Let's go again, sorry. This is d squared into kex minus d into kex minus 6 times kex equals 2e to the x.
All right. This squared symbolizes or means the second derivative. Okay, it means the second derivative. Now, what is even the first derivative? That's the question we should ask first. What's the first derivative? If I differentiate ke to the x, kex, I'm still going to get kex. Yeah, k is a constant. Differentiate e to the power of x, it is still e to the power of x. So even if I differentiate this one 10 times, I'll still get kex. So this means that the second derivative of kex is still ke to the x minus, differentiate this is tke to the x minus 6ke to the x equals 2e to the x, all right? This will cancel out. So what do we have? We have minus 6kex is equal to 2ex. So if I compare coefficients, it means that minus 6k is equal to 2 by comparing of coefficients. So we have minus 6k equals 2e, equals 2, not 2e. So dividing both sides by minus 6, k will be equal minus 2 over 6, and that's equal to minus 1 over 3. Therefore, the solution to this equation, y, we said it is particular integral or complementary function plus particular integral, that's yp. And our complementary function, in this case, we have it is there ae to the minus 2x plus be to the 3x. And then what's the particular integral? The particular integral is ke to the x. But we've gotten k as minus 1 over 3. So the particular integral will now be minus 1 over 3 e to the x. And this is the general solution to the differential equation that we have as the question. All right, let's see the next question. Remember to subscribe, like, and share this video to your friends and to your classmates. Here is the next question. It is still non-homogeneous. You know, our focus in each of these solutions is the right-hand side. So we are having a trigonometric function on the right-hand side, and that is 25 sine 2x. Okay, quickly, let's determine the complementary function. As usual, this will be 2d squared y minus dy minus 3y equals 25 sine 2x, right? Then we have 2, okay, let's set the auxiliary equation. The auxiliary equation will be 2m squared, all right, minus m, you get it, minus 3 equals 0. That will be the auxiliary equation from this left-hand side. So, solving that auxiliary equation, what will it produce? 2 times 3 is 2 times minus 3 is negative 6. Two numbers whose product is minus 6 and whose sum is minus 1. The numbers are 2 and minus 3 because 2 times minus 3 is minus 6 and 2 plus minus 3 is minus 1. So that equation simplifies onto 2m squared, okay, plus 2m minus 3m minus 3 equal to 0. So factorizing, we have 2m can come out. We have m plus 1. Then minus 3 can come out. We have the same m plus 1 equal to 0. So solving that equation yields 2m minus 3 into m plus 1 equal to 0. Are you there? And this will result to m equal to negative 1 or m equal to positive 3 over 2. I just solved that equation. And these are the roots. So the complementary function yc is equal to ae to the negative x because of this negative 1 plus be to the positive 3 over 2x. Get it? That's the complementary function. So, we've not really solved questions that give us complex roots, right? Yeah, or real and equal roots. It does not always mean that any time we solve the left-hand side, we are going to obtain real and different roots. We may have the same roots that are real numbers and they are equal. We may also have the same different numbers, okay, like in this case now, they are real numbers, but they are not equal to each other. And lastly, we may have complex roots. So that notwithstanding, let's proceed. Let's determine the particular integral. Remember, we said that for a trigonometric function of either sine term or cosine term, or a sum or difference of the two terms, sine and cosine, the particular integral for sine 2x in this case, let the particular integral, which is v, be equal p, let's use p and q, p, or let's use p and arrow, p sine 2x plus arrow, arrow cos 2x. This will be the particular integral. Arrow cos 2x. All right. This particular integral is used, like I said earlier, when we have sine terms. If I had just sine 2x, like as it is now, I have sine 2x, I can use this one. If it is still cos 2x, I'll still use this. If it is sine 2x plus cos 2x, I'll use this. Good, get it? So let's proceed. It will be very, very wise for us to first of all differentiate this before we proceed into the operator D format. If I differentiate, let's say dv, I differentiate this now, what will I get? Differentiate sine to get cosine, right? But because of this 2 there, it's going to be, the 2 multiply the p outside, 2p cosine 2x, plus differentiate cos to get minus sine. So I want to just write my minus. Then 2 times arrow is 2 arrow sine 2x. I've differentiated p sine 2x plus arrow cos 2x. That's the first derivative of that particular integral. I want to get the second derivative, which will be 2d squared v. I will now differentiate everything here. Okay, differentiate cos 2x. Actually, the derivative of cosine is minus sine. So I'm going to bring the minus outside. This 2 here will multiply what is outside before. That will be minus 4p sine 2x. Then differentiate sine to get cosine. But there was a minus before. This 2 outside multiplies this one to give me 4 arrow. You get it? Then we have cos 2x. This is d square v and this is dv. So we can easily place this. We can easily do the substitution now into the operator D equation. Let's go, follow. This is the operator D equation, right? So let's plug it in now. We have 2 into d square y. Okay, whereas d square y is our d square v here, you know that. Yeah, this is equal to our particular integral. So I will just write everything here in place of the d square y. So this will be 2 into everything that's that are underlined. Minus 4p sine 2x minus 4 arrow cos 2x. You get it? Then let's go. Minus dy. that'll be minus, what's dy? This is our dy. That'll be 2p cos 2x minus 2 arrow sine 2x, then minus 3y, and y is the particular integral itself. So I will use 3 to times everything here. In fact, minus 3. Minus 3 times everything here gives me minus 3p sine 2x, then minus 3 arrow cos 2x. Everything is equal to the right hand side, 25 sine 2x. 25 sine 2x. Straightforward. You've been following the solution and it's not difficult at this point in time. I'm going to open the bracket now so that I can equate coefficient that corresponds. 2 times minus 4p is minus 8p. Let's go. Minus 8p sine 2x. 2 times minus 4r is minus 8r cos 2x. Okay. Minus 2p. Okay, the minus goes inside the bracket. Minus 2p cos 2x plus 2r sine 2x is equal to what? Okay, this is not equality, that's a minus. Minus 3p sine 2x, then we'll have minus 3r cos 2x, everything is equal to 25 sine 2x. Straightforward. All right, let's equate coefficient. At the right hand side, for sine, we have 25. Look at it for sine, the one that has to do with sine 2x. Then on the left hand side, we have minus 8p, we have 2r, we have minus 3p. So let's go. Minus 8p plus 2r minus 3p is equal to this 25. You get it? Minus 8 minus 3p is minus 11p. So negative 11p plus 2r is 25. Let's call this equation 1. Okay, going forward, for cosine, we have three. How many cosine terms do we have at the left? We have 1, we have 2, we have 3. That's minus 8r minus 2p plus, okay, minus 3r. There is no cosine term at the right hand side. It is just sine term. So because there's no cosine term, we set that equal to 0. That's what it means. Minus 8r minus 3r is minus 11r. Then we have the minus 2p equals 0. Okay, we can easily solve these two equations. Let me split this. Let's go. So this is, let me rearrange this equation to be like this. Since p comes before arrow, let's say this is minus 2p minus 11r equals 0. And as a matter of fact, the two of them have minuses, so I can easily remove these minuses by dividing both sides by minus 1. If I do that, the minuses will disappear. Okay, so I'm going to get 2p plus 11r equal to 0. Question 2. The target is to solve the equations for p and r, and then we are there. We have gotten our particular integral. So this is 11, this is 2, this is 2, this is 11. So to solve for p and r by method of elimination, I want to solve the two simultaneous equations, okay, for p and for r. P has a coefficient of minus 11, and for p here is 2. We have arrow 2 here, arrow 11. Okay, so let's eliminate. Let's see, we're going to eliminate p for example. Okay, to eliminate p, multiply this one by 11, multiply this one by 2, times this by 11, times this by 2. You get it? So if I times equation 1 by 2, I'm going to get, am I right? Yes. Minus 22p, follow me, from equation 1, plus 4 arrow equals 50. Let's call this equation 3. If I times equation 2 by 11, this will give me 22p plus 11 times 11 is 121. 121 arrow equals 11 times 0 is 0. Equation 4. So to get the value of p, they are the same except for the sign. Sorry, except for the sign. I can just add equation 1 and 2 to eliminate that p. So if I add equation 3 and 4 rather, not 1 and 2, this plus this is 0. 4 plus 121 is 125. 125 arrow equals 50 plus 0 is 50. So it means that arrow is actually 50 by 125. Okay. 5 here is 10. 5 here is 25. We can still go again. 5 here is 2. 5 here is 5. So this means that arrow is 2 divided by 5. Let's keep this one. We now determine the value of p if arrow is 2 over 5. For value of p, I'm going to substitute 2 over 5 for arrow into any of the equations into equation 1, 2, 3, or 4. Let's use equation 1. So it's going to be like this. Minus 11p from equation 1 now. Minus 11p plus 2 times arrow, which is 2 over 5, is equal to 25. So you have minus 11p. 2 times 2 is 4 plus 4 over 5 equals 25. So we have minus 11p equals 25 minus 4 over 5. You get it? Okay, look at the maths. 5 times 25 is 125. 125 minus 4 is 121. So this right hand side is 121 over 5. You get it? So 11 divided 121 11 times. What does this mean? This means that negative p is equal to 11 over 5. If the minus crosses, it means that p is minus 11 over 5. So this is p. The particular integral v is p sine 2x, right? Plus arrow cos 2x. P is minus 11 over 5. Arrow is 2 over 5. This is the particular integral. So what is going to be the general solution now to this differential equation? General solution is simply particular integral plus what? Complementary function. The complementary function, what is it again? And the complementary function, by our calculation, is ae minus x plus be 3 over 2x. So let's write that down. You have, it is equal, y is equal to ae minus x plus be 3 over 2x. Then we'll add this one to it. Okay, minus 11 over 5 sine 2x plus 2 over 5 cos 2x. This is the general solution to that second order non-homogeneous differential equation. Let's determine the general solution to this differential equation. 8d squared y dx squared minus 6dy dx plus y equal to 2x plus 40 sine x. Okay. All right. As we used to do, let's determine the complementary function. In d operator form, the left-hand side is 8. d square y minus 6dy plus y equals the right hand side. Good. Factor the y out. 8d squared minus 6d plus y. Okay, the y is going to be outside. If I'm going to bring the y outside, I have 1 left equals 2x plus 4t sine x. So let's frame the auxiliary equation from the left hand side. We're going to get 8m squared minus 6m, all right, plus 1 equals 0. So two numbers whose product is 8 times 1, 8, whose sum is minus 6. The numbers will be minus 2 and minus 4, right? So we have, okay, look at it, minus 2 minus 4, because minus 2 times minus 4 will give me a plus 8. Minus 2 plus minus 4 gives me minus 6. So what I'm going to do now is this. It's very easy. Just simply say that. I want to use a short way to solve the equation, okay? The numbers are m equals to minus 2, m equal to minus 4. Like I said earlier, divide this one by the 8. Divide this one by the 8. Change this sign from minus to plus, from minus to plus. Simple. So what does this imply? M is simply 1 over 4, or m is simply 1 over 2. So we have real and distinct roots. The complementary function is going to be AE 1 over 4x plus BE 1 over 2x, okay? The next, which is usually the most hectic part of the solution, is the calculation or determination of the particular integral. So in this function, at the left hand side, we have at the right hand side, we have a sum. Look at it, 2x plus 40 sine x. So I'll be choosing two separate functions for this particular integral because I have the sum of two functions here. 2x is algebraic, 40 sine x is trigonometric. If you follow the principle I gave at the beginning of the video, I said that if we have a polynomial like this, like x of degree 1, we are going to assign a function, actually a polynomial also of degree 1. You get it? So what will be the particular integral of 2x, for example? 2x is a function of x, algebraic function, that has the power of 1. So the particular integral for 2x should be k x plus, let's say, L. That's how we assign for 2x. And if it is 2x squared, it's going to be kx squared plus lx plus, let's say, n. You get it? Then what will it be for sine x? For sine x, we are going to say it is m cos x plus n sine x. So this one corresponds to 2x. This one corresponds to what? 40 sine x. So this will be our particular integral. This is the guess. This is how we do it. Everything here is equal to the particular integral, and that's v. All right, let's proceed now. It will be very wise for us to differentiate this first, since the function is it has multiple terms. You get it? So let's differentiate before we plug into the d operator equation. If I differentiate v, differentiate ks to get k, differentiate l to get 0, differentiate cos s to get minus sine x. Okay, minus sine x. Let's go again, sorry. It's going to be dv equals k minus m sine x. Differentiate sine x to get cosine plus n cosine of x. Good. Let's differentiate this for the second time to get the d squared v. So what will be d squared v? Differentiate k now to get 0. because k is a constant. Differentiate sine to get cosine. So we have negative m cosine of x. Differentiate cosine to get minus sine. So we have minus n sine x. You get it? So this is d square v and this is dv. Let's now go to the auxiliary equation. This is the d operator equation. Let's substitute. So we have 8 into this. You know how it has been. We have 8 multiplying everything here. As a matter of fact, I can just go straight and say minus 8m cos x minus 8n sine x. Then use this minus 6 to times everything here, which is the first derivative. Minus 6k plus, this is minus, so minus is a plus 6m sine x minus 6n cos x. Then we have 1. 1 times y is y. Okay, look at it, y. And y is the particular integral itself, which is everything here. So I'm going to write everything there. That's plus kx plus l plus m cos x plus n sine x equal to the right hand side. That's 2x plus 40 sine x. All right. So let's do the comparison. Let's compare. There is only one term in x here, kx. So compare this k and compare this one. We're going to say that k is equal to 2. So k is equal to 2. That's the first answer. We have to get m, n, and l now. All right. Minus 6k is a constant. L is also a constant. Those are the only constants we have at the left-hand side. At the right-hand side, there is no constant, so we say it is 0. You get it? So it means that minus 6k plus the L at the left-hand side equals 0 at the right-hand side. Whereas k is already 2. So everything here is minus 12. Minus 12 plus L equals 0. And this implies that L equals 12. Good, we've gotten the second one. K is 2, L is 12. So let's handle the other part of it. We have M and N left. For N, okay, we have sine, sine. Minus 8n, let's compare their coefficient. Minus 8n plus 6n. Okay, plus n is equal to 40. That's the sine function we have. Minus 8 plus 1 is minus 7. Minus 7n plus 6m equals 40. Let's call this equation 1. You get it? Then we have, for cosine, this is cosine, minus 8m minus 8m. All right, for cosine then we have minus 6n and plus m. There's no cosine term here at the right hand side, so we set it equal to what? 0. Minus 8 plus 1 is minus 7. So we have minus 7m, then minus 6n remains. Everything is equal to what? 0. Equation 2. So let's solve for n and m. As a matter of fact, minus can be taken away to give me plus. If I divide through by minus, it gives me a plus. So the minus there is out. You get it? So let's solve equation 1 and 2 to determine the values of m and n. Let's multiply equation 1 by 6 and equation 2 by 7. Times 6, this gives me minus 42 n plus 36m equals 240. Equation 3 times 7, 42n, okay, plus 49n equals 0. Equation 4. I can easily eliminate n by adding equation 3 and 4. If I add this together, it turns 0. 36 plus 49 is 85. Yes, 85. So I have 85m. 9 plus 6 is 15. Yeah, 85m is equal to 240 plus 0 is 240. Divide both sides by 85. So what is m? 5 here is 5 here into 85 is 17. 5 here, okay, that will be 20 is 4, remaining 4, 48. So n is 48 over 17. Settled. What's n? Let's do for n now. Let's plug in 48 over 17 for n. Okay, do the maths yourself. Substitute, you're going to get n equals negative 56 over 17. Yeah, verify. Let me leave this one for you to verify. So if this is true, it means that the general solution is the sum of the particular integral and the complementary function. So what is the complementary function first of all? It is, we got to it before. We have the complementary function already. AE 1/4 x, BE 1/2 x. So we have AE 1/2 x. Okay. It doesn't really matter if I write A or B first though, but let me follow the write-up. AE 1/4x plus BE 1/2x. Then I'll add the particular integral to it. And what was the particular integral? The guess is kx plus L. Look at it. Kx plus L plus m cos s plus n sin x. K is 2. L is 12. M is 48 over 7. N is 56 minus 56 over 17. So I want to plug in those values for K, L, M, and N respectively. And this will be the answer. K is 2. So we have 2x. L is 12. We have 12. Okay. M is 48 over 17. Then there's equals S. You get it? Then N is what? Minus 56 over 17. There's a sin X. And this is the general solution, to the second order non-homogeneous differential equation. I hope you enjoyed watching the video. Don't forget to subscribe, like, and as well share the videos to your friends, to your classmates. I'm going to see you in the next video. Enjoy.